or writing formulas. All right, so writing formulas from names, we'll start with covalent because that's the easiest. Right? So it's got prefixes. So follow prefixes. And that's it. Right? If you see prefixes, just follow them. So if I said diphosphorus pentoxide, how many phosphoruses are there? 2. How many oxygens? 5. So P2O5, right? So if it's got prefixes, follow them. That's it. All right. So what about the other one? So what if they don't have prefixes? Let's see. That'd be ionic, right? Ionic, first thing you want to do is you want to find what we call the charges. When we went over polyatomic ions, do you remember me talking about those charges? Where are the charges found? On the polyatomic ions, where are the charges found? Yeah, superscript, the one that's one up there, right? So there are positive ones, there's negative ones, and negative ones, negative 2, negative 2, and negative 3. So those are called charges, right? So for the elements, we need to find the charges. So I'm going to give you a way to find the charges using the periodic table. So the periodic table that we colored, we're going to add some more stuff to it. Okay, now this is a trend, which means pattern that you can follow all the time. All right? There's a few things you have to remember, but mostly it's a nice pattern. So the first column here, see this first column here with hydrogen, lithium, and all that stuff? Right? These have a charge of +1 when they make an ion. So hydrogen, even though it's a non-metal, sometimes acts like a metal. Okay? Even though it's a non-metal, sometimes it acts like it acts like a metal because it's in a column of metals. But it's still a non-metal. It just has properties of a non-metal sometimes, or a metal sometimes. All right, everything here has a charge of +2. We're going to skip the middle for now. The middle part right here where you can see Roman numeral 3b, Roman numeral 2b, we're going to skip those and go to the column that has boron at the very top. This has a charge of +3. Carbon and this family have a charge of positive and negative 4. Okay? Now, when it says positive or negative 4, that doesn't mean carbon is both positive and negative. No, it's one of them. Okay? It's either the positive or it's either the negative. Some of these are just positive 4. Some of these are negative 4. So that's why this column is a positive or negative 4. This column right here is a negative 3. Everything in this column has a charge of negative 3. Everything in the oxygen column will have a charge of negative 2. Everything in this column will have a charge of negative 1. And the noble gases in this column here have 0 charge because they don't form compounds. So it goes 1, 2, skip the middle, 3, positive, negative 4, negative 3, negative 2, negative 1. See that? You see that pattern there? You think you memorize that pattern? Now, there are a few of them that we're going to add here that doesn't follow the pattern. All right? So remember how we skipped the middle part? The reason why we skip the middle part is because, for example, copper can have more than one charge, meaning it could be positive 1 or it could be positive 2. All right? Things like gold can be positive 2 or positive 3. So that's why we're not writing things in the column because they kind of vary. Except for zinc. Zinc is always positive 2. And silver is always positive 1. That's just something you have to know. Okay? Zinc is plus 2, silver is positive 1. Tin and lead. Tin and lead are other exceptions here. Tin can either be a plus 2 or a plus 4. Plus 2 or plus 4 for tin. Lead is the same way. Lead can either be positive 2 or a positive 4. Now, where are the metals located on the periodic table? On the left side, right? Notice what the charge of all of the elements on the left side are. Positive or negative? They're positives. Metals are always positive. Now the nonmetals, notice what the nonmetals are. Negative. Nonmetals are always negative. Okay? So remember this column that can be a positive or negative 4? Carbon, since it's a nonmetal, would be a negative 4. Where the guys down here, tin and lead, are both metals, and they would be positive 4. Any questions? Yeah, Matthew. Positive 2 or positive 4. Louis? The metalloids? The metalloids, well, since they are metalloids, they would have buried charges. We're going to stay away from the metalloids for now. We'll come back to it, and I'll tell you when we learn a little bit more about how they work. Yep.
The nitrogen family is negative 3, then what is Bi?
You mean B?
No, Bi.
Oh, negative 3?
You said metals are always positive.
Right. Well, down here, we're not really concerned with many things down here because they don't form compounds, but it would also be a negative 3. Okay. Now, these rules that I give you, there's always going to be a little bit of exceptions here and there. Okay, is there any other questions? All right, now that you know the charges, the next thing we do is, after you find the charges, that you're going to balance those charges to 0. Okay? All right, so to give you an example, let's say I had a metal, aluminum. Let's say I had aluminum as my metal, okay? And then I had my nonmetal as chlorine. All right? According to the periodic table, what's the charge of aluminum? 3, thank you. 3, right here. So the charge of aluminum is plus 3. And according to the periodic table, what's the charge of chlorine? Minus 1. If you were to add 3 and negative 1 together, do they equal 0? No. All right? So which one would I need more of to make it 0? Chlorine. And it's as simple as whatever number I put down here, okay, is how many I have. So with 1 aluminum, that's a positive 3. How many chlorines do I need total to give me a negative 3? 3 of them. So I would put a subscript there for 3, and that would mean I have 3 aluminums, each with a negative 1 charge. Right? And then now that this is perfectly neutral, that means positive and negatives bounce out, right? We can drop those charges, and it's just AlCl3, and that's the formula for aluminum chloride. Okay? See how the charges work to make the formula? Now, how come we can't do this for everything, like the covalents? Well, if those 2 covalents, like nitrogen and oxygen, what's the charge of nitrogen? Negative 3. What's the charge of oxygen? Negative 2. Can they ever add up to 0? No. That's why we use prefixes with the covalents, because the charges never equal to 0. See that? Make sense? Any questions? Questions? All right. So let's look at this. Oh, before we go, put a 3, skip 2 spaces, put a 4, and skip 2 spaces. Okay? Remember, today we're just doing binary compounds. All right. So if we look at here, all right, we got binary ionic compounds, binary covalent compounds. Okay? So let's do a few of them together. So the first is calcium bromide. Calcium bromide, what's the charge of calcium on the periodic table? +2. I'm just going to write it here so I don't mess up my final answer. I could put my charge anywhere. I'm just going to put it on the words. Okay? And then bromine, what's the charge of bromine? -1. Okay? Now, what I noticed, the key to success for people who do well on this is they write their charges out. All right? People that mess up, the first thing I tell them to do is write their charges because that's something they never do. Even the people that are really getting it, they still write the charges out because it helps them. So just get in the habit of writing your charges out. All right? So if I'm looking at this, calcium is +2, bromine is -1. Right? What should the formula be? Calcium is Ca, bromine is Br. So what should the formula be? CaBr2. We did that from the charges. Okay. What about aluminum? Remember the charge of aluminum? +3. Charge of sulfur? -2. All right, if we're looking at this, all right, how can -2 add up to 0? Right. We're going to need the common factor. Common factor between 2 and 3 is 6. So if I can +6 and a -6, that's out to 0, right? So how many aluminums do I need to get a +6?
2.
So it's Al2. How many sulfurs do I need to make a -6?
3.
So it's S3. So aluminum sulfide is Al2S3. Think you got a handle of that?
Yep.
All right, so for homework tonight, you're going to go all the way up to 15. And then you're going to do the entire column of the covalent compounds. Okay? The covalent compounds, boron trichloride. Formula? B. Chlorine is Cl3. See how fast that is? Boron trichloride, you would just follow those prefixes. So you're going to do up to 15 here. You're going to do the 20 on this column. Okay? Now, on the back side, we should have up to 10, right? All right, just so that you don't lose it, I would like you to go up to 15 for each one, so an additional 5 on those sides, okay? Got it? Any questions? Okay, so we're going to start. We got 20-some minutes for our quiz, which is plenty of time, okay? So let's clear this out. You have something to do if you finish early.